So let's have a look at the advanced settings of a particle playground system. Here in the inspector, at the very bottom before the playground manager, you'll see the advanced tab. The first thing here you'll find is simulation space, where you can define if the particle system should be simulated in world or local space. And in world space, the particles will move. It won't be affected by how the source is moving, but in local space, it will just tag along the source. You'll also see here that when we change to local, it's telling us that you have the same source transform as your particle system. So this is not preferable when you want to use movement compensation or the compensation lifetime strength. So let's create a new game object there and assign that and kind of drag that in a bit. So right, so now if we want to, as you can see, we have this movement compensation still when moving this other transform. But if we were to want to have some slack to this, to kind of transition between local and world space, we could apply a compensation lifetime strength to our particles, where you probably at most times would want to have sort of an initial compensation, full compensation, and a zero compensation in the very end. So what will happen now is that we have it will try to compensate for the repositioning of the source, but give it some slack over time. So that is good to know. If you, for instance, have this effect from a jet plane or something where the smoke is the smoke particles are too far apart because the jet plane is traveling too fast between particle emissions, you could apply this effect. Try that out to see if it mends the issue. And then we have this thing called time, where the update rate will determine how the particle system is updated, how often. Having that set to 1 will update it each frame. Having it set to 2 will update it each second frame, and so forth. And this could be useful if you have particles that isn't moving a lot or isn't changing a lot in size or color, and you could probably move this down a bit to spare some CPU cycles. Then we have this thing called timescale, where you can set the timescale of your particle system locally, and if you want the particle system to pause, you'd set this to 0. And then we can find something called Rebirth options here, where you can determine how a particle birth should behave, where if it should get a random lifetime, if you have minimum to maximum lifetime set, give it random size, random rotation, if scattering should be random, if random velocity should be applied, if you want to force the initial color of the particle system, if you want to apply delta position adjustment. And what that is if you experience a non-linear movement of particles For example, let me show you. We have, if we try to do this sort of linear, emit everything from a line, let's set that to 0. What we need to do is to have the lifetime not scrambled, but either linear or scrambled linear. And you still see that the particles are sort of emitting in clusters, and this is because the lifetime when the birth event should happen, you might not have a frame available exactly at that moment, so it starts to kind of cluster these together. And what this will do, delta position adjustment, is to just mend all the full distribution of the force applied. And what you'll also see is that it needs to break that from the beginning, so you kind of get this sort of behavior going on as well. But just be aware of that. There are ways to work around that visually if you really need this sort of super linear behavior. And then you can also determine here if you want to calculate the manipulators immediately on Rebirth. And moving on, you can apply locks here. If you, for example, have a particle system which is instantiating with another transform as a parent, and you want to move that transform around but not the particle system, you can apply different locks here. When the particle system is enabled, you can tell it to pre-warm. We could actually use this effect we've got going on here. If we press play, you'll see that it will start from the beginning of the source there. But if we would want to pre-warm that, we could just we enable that, and it will start with the full line there. As you could see, the rebirthing, it won't work in the first initial lifetime cycle there. That's a limitation which hopefully will be worked around soon. Okay, so you can also apply this out of view auto pulse calculation thing, where if the camera is not rendering the particle system at the moment, you can make it pause, and then you can have this trigger for at what position the camera should start to calculate the particle system. And then you'll also find something here in miscellaneous called sync particles to main thread, and this will make the particles at the final step after calculations are done. It will send all of these to the main thread to be synced to everything else. So if you see any glitchy behavior in movement, or when you use texture atlas animation, you might want to sync the particles here. And then you can also specify which thread method this particle system should use, if it shouldn't be multi-threaded, or if it should use one per system, which is this will require an extra thread, and if you would want to use one for all, having a lot of particle systems, if we were to have a lot of these effects, right, they're using the same. So let's say we have 3 of those, and we have all of these set to 1 for all. These all will be calculated on the same thread. Kind of, yeah, advanced feature, but available here for tweaking. And then you can clear out and rebuild the particle pool as well. So that's about it. That's the advanced features of a particle playground system currently. Thanks a lot for watching. Have fun in the playground.